about it when we talk about machine learning in general. But if you remember, when we talked about different categories of machine learning, we had supervised learning, unsupervised learning, and reinforcement learning. Okay, so in supervised learning, the important point was we have output values. So we care about predicting a specific output value, either continuous in the case of regression or categorical in case of classification. Okay. In unsupervised learning, on the other hand, we don't care about the labels. We just want to identify some patterns between the features or data points that we're going to go through it later on. And then we talked a little bit about reinforcement learning that we are not going to go through in this course. But let's see an example and understanding what we mean by supervised versus unsupervised learning, because in general, fully comprehending these two concepts and understanding the difference between them is very important in the beginning of your learning journey in machine learning. So as I said, we don't have any knowledge about outputs or labels in unsupervised setting, while in supervised setting, we know about the labels or output values if it's continuous. And the goal of supervised learning is predicting those labels or output continuous variables. But in unsupervised learning, it's mainly about pattern identification and grouping data points or features together. Imagine you have these data points. Very simple example. This is not something necessarily you deal with out there in real tasks, but it's very easy to comprehend the differences between supervised and unsupervised learning. So in case of unsupervised learning, you have these data points, but you don't have any label. And by label in the picture, I mean the colors, okay? But in the right side, you can see colors, which means that there are two labels, two colors. We have red label and blue label. Okay, so the difference is exactly this. So in case of supervised learning, you know the labels and you want to use those labels for classifying new data points. If we have a new data point, we want to see which group we want to assign that new data point to. But in unsupervised learning, we just want to identify the groups, identify some patterns between the data points, and then move on. So in this case, in case of unsupervised learning, we have two groups. We just group them. We don't know what's going on within those groups necessarily because we don't have any label. So just one important note. Sometimes we have the labels, but we don't want to use those labels. That's very important in case of unsupervised learning. Sometimes we try to cluster them, use unsupervised learning approaches to cluster and group those data points, and later on check what the labels of those data points are. Okay, so we are not using the labels, we just later on check the labels of those data points within those groups. Okay, but in case of supervised learning, we usually want to find something that's called decision boundary. So the decision boundary in this case is a line, for example, if we consider a linear approach. And this decision boundary tells us that we have one class above it and one class below it, which is red and blue in this case. Okay, this is a very simple case, as I said, but in this case, we have two features or two dimensions, as you can see as X and Y axis, but in reality, you have many, many features and maybe more data points, or sometimes, unfortunately, less data points. You may deal with multi-class classification. Here we have binary classification, which means that we have color red and color blue. So two classes is binary classification, but in many cases, you're dealing with multi-class classification. A good example is digits. For example, you have class 0, class 1, class 2, class 3, class 4. So each digit is a class for you. So, and then you want to predict the classes of the images that you have, which are associated with a specific digit. Okay. So as I said, we want to focus on supervised learning in this session. Just very brief review. We have supervised learning in case of continuous variable for regression, and categorical variable for classification. Logistic regression. So logistic regression, is for classification. So in linear regression, you're trying to identify a continuous value as your output variable. But in logistic regression, instead, you want to do classification. So your y values are either, for example, 0 or 1 in case of binary classification, or it could be multi-class classification that we will go through it later on. But imagine you're dealing with binary classification, 0 and 1. And this 0 and 1, remember, the 0 and 1 value doesn't matter. Those are classes. It could be apple and peach. It could be cat or dog. So 0 and 1 are just two numbers representative of those two classes. That's it. So in case of classification, we use logistic regression, but the model is still linear, and that's very important. That's actually one of the interview questions that you may deal with if you want to get into machine learning engineering or machine learning research or data science jobs. That logistic regression is also a linear model, but we use it for classification. Okay, and this is how it works. Instead of having a linear summation of the features, we have a linear relationship with the feature, but we apply another complementary function, which is called sigmoid function. I will present it in the next slide. And that converts your values, your output values, to a binary class. And this is how it works. So you have the linear summation, and then you put it in the sigmoid function for logistic regression. So here, this linear summation that you use for linear regression now goes to the power, so it will be 1 over 1 plus e to the power of this linear combination. Okay, but why this works? Imagine you have these ones to be 0. What happens? If summation of x's plus the bias is close to 0, you have 1 over 1. Okay, so the value will be 1. When you increase x values, when you increase that power of the exponential function, you're increasing the value in your denominator. Then your function goes to 0. Make sense? So when it goes to 0, it means that you're approaching to the other class. And then you have a middle point that determines if you want to choose class 1 or class 0. Was it clear? So I will describe this cost now if there is no question in this part. Okay, so in case of, so I'm going to explain it a little bit, then we have to move a little bit faster because we have to go through the code as well, but I'll try to answer all of your questions. If you have a question and I didn't answer it properly, you ask me again in Slack and I will explain it, or I will record something for you. Okay, so in linear regression, you have linear combination of features that predicts your y values. In case of logistic regression, you have the same linear combination, but you put it in the sigmoid function, which is this function, and that converts it to this kind of relationship that gives you one class versus another. Instead of having a linear relationship, now you have this sort of curvature, and that could separate your data points to one class versus another. Okay, but if you don't mind, we have to move. So let me see if there is, okay, perfect. So, and the cost function in this case, instead of having the mean squared error, we have other cost functions. I will go through it later on. That is based on the difference between the actual labels and the predicted labels instead of actual value and
the packages that we want to use. First, we need to import these packages. You can see that how we import these packages here. We import NumPy, we import Matplotlib, and also pandas. And after that, we just need, since we are using Colab, we just need to mount the directory that we want to use from the Colab here. If you are not familiar with the Colab, there's a document for that, and we can share this document for you with you, that how you can implement the code and how you can run the code with the Colab. It's easy. You can just use shift and return if you are using the MacBook, and if you are using the Windows, you can use a shift and enter for running each cell in this Colab. Colab contains some cells that these cells are codes, and also some text cell that you can develop and also describe the code in these cells. And to mount a directory, you need just use this directory, and as you can see here, I already mounted directory here. So let me just rerun this code to show you that how I can mount the directory for Colab. I will show you in the at the end of the session how we can mount here. Let's see, what is the question? Actually, since we want to use a directory and in the Google, we just need to mount that. Let me rerun. Okay. And so after mounting this directory, we just need to read some data, and you can just read the data from the directory that you already mount, or you can also use some other paths to read the data. As you can see in this cell, I just used a URL to read CSV file. But here I put the CSV file in this path, and I just read this CSV file from this path. The first code here is an interaction shell, and it helps us to run all the code and also show that to you that how these codes are running. And let's see, with this code, which is the part of the pandas, we just read CSV file, and from this path. This is the path of the CSV file that we have, and we read this CSV file and put this CSV file as a data frame to data set. And as you can see, we have this data set here. And if you just want to use this column as an index, we just need to say that index column is equal to 0 because it's the first column. So here, instead of having one more column that is not useful, we just use the first column as an index column. After that, we just want to load the data set. Ali described the Irish data set to you, and there are different types of Irish flower. And we just want to specify this type based on the sepal and also petal of these flowers. If I want to remind you of how I described that we have 3 types of the Irish data, and we just want to specify this data by petal and sepal of them, and we have is our model. To see how good is our model, we just check if the prediction is matched with the real value or not. To do that, we have some performance measure. This performance measure, I want to describe this performance measure. Whenever we have binary classification, we just check that if each value that we predict is exactly equal to the real value or not. Let's say that we have two different classes. We say that our prediction is specified in some part of the classes and specify each item of that class as a, let's say that we have positive and negative, as a positive or negative. So whenever we predict correctly the positive value, we say that we have true positive. Whenever we predict incorrectly the positive value, we can say that we have false positive, and vice versa. Whenever we predict the negative value correctly, we can say that we have true negative, and whenever we predict the negative value incorrectly, we can say that we have false negative. And in this case, we can somehow say that how our model is correct. We use confusion metrics to show you that how how correct is each true positive and true negative. And I will show you in the next code. But whenever we want to check the performance of the model, we use precision, recall, specificity, and also accuracy. Whenever we are using precision, we just want to see that how many selected items as a positive are relevant. And whenever we and the formula is here. And whenever we use the recall, we want to see that how many relevant items are selected. And the formula is here: true positive over true positive over true positive plus false negative. And for the precision, we have true positive over true positive plus false positive. And specificity is true negative rate is true negative over true negative plus false positive. And what accuracy is? Most of the time we use accuracy to find the to evaluate our model, is the number of correct prediction over the total number of the data points that we have. Whenever I set the correct prediction, I mean that we have true positive and true negative over all the data points that we have. So we just count the number of the points that we predict positively, correctly. And the balance accuracy is recall and specificity over 2. I will show you the confusion matrix. Confusion matrix shows the true positive, true negative, and false positive and false negative. And I will show you in the next codes. Then you can have a better understanding of that. Let's see that how we can find this evaluation. We just use metrics from Scikit-Learn. So we import metrics from Scikit-Learn. And after that, from the matrix from Scikit-Learn, we can see the confusion matrix for Y test and Y prediction. And also here you can see the confusion matrix. Here we have 3 classes. We don't have 2 classes. So for each of them, we can say that each of them is a type of the flower, and the column in